Welcome to qnawire.
For this question, we're asked to draw the energy level diagram for these lowest few levels, assuming that the higher levels are closer together here. So suppose the ionization energy is 4.10 electron volts. That means the ground state, E1, is negative 4.10 eV. And then we're given these different wavelengths from emission lines here. So we're going to use the fact that the energy of these emission lines is going to be equal to hc over lambda. And so we can use the fact that this energy is the energy difference between energy levels and find the value of these different energy levels. Okay, so we have the first one. We have delta E. We'll call this delta E2. Delta E2 is going to equal to hc over lambda 2. For Planck's constant, using the electron second version, so that way we can get our answer in electron volts. And this comes out to equal 4 electron volts. Okay, so now we can find, since we're going to say that this value to E2 is equal to E2 minus E1. Remember that E1 is negative. We can solve for E2. We have E2 is equal to E2 plus E1. Again, where E1 is negative. Oh, this is supposed to be 4.00, not 4.10. Sorry. And we get 2 is equal to negative 0.1 eV. For the next one, say that delta E is going to come from taking our value here, c over lambda 3. Therefore, E3 is going to be equal to delta E3 plus 1 comes out to equal 1.0, negative 0.0 eV. Okay. And then now for the last one, we get a value. So we could call this delta E4. Which also comes hc, but this over lambda. Comes out to equal 0.9 eV. Here, we're going to use a value. We're going to assume that this is the energy difference between the second and the third energy level, right? So you have it going from 3 down to 1, 2 down to 1, and it also needs to be able to go between 3 and 2. So that's going to be this one here. So what we have is a value we can call E4, which is equal to delta 4 plus 1. Me, E3 comes out to equal, again, negative 0.1 eV. So now we can construct the energy level diagram. It's going to be our E equals 0, N equals infinity. Have negative 0.1 EV for the second excited state. Then at the very bottom here, let's go ahead and draw the ground state. N equals 0. We have negative 4.1 EV. And then the difference between the ground state and the first state is 1 EV. And then the difference between the ground state and the second excited state is 1.1 EV. So this is equals 1 goes here. Okay, so when it transitions this direction here, we get the wavelength lambda 3. This length here gives us lambda 1. And this transition here gives us lambda 2.